What we're going to do using our powers of calculus is find the area of this yellow region. And if at any point you get inspired, I always encourage you to pause the video and try to work through it on your own. So the key here is you might recognize, hey, this is an area between curves. A definite integral might be useful. So I'll just set up the definite integral sign. And so first we need to think about what are our left and right boundaries of our region. Well, it looks like the left boundary is where the two graphs intersect right over here, and the right boundary is where they intersect right over there. Well, what is this point of intersection? It looks like it is -1, -2. We can verify that. In this red curve, if x is -1, let's see, you square that, you'll get 1 minus 3. You do indeed get y is equal to -2. And in this blue function, when x is equal to -1, you get 1 minus 4 plus 1. Once again, you do indeed get y is equal to -2. And the same thing is true when x is equal to 1. 1 minus 3, -2. 1 minus 4 plus 1, -2. So our bounds are indeed, we're going from x equals -1 to x equals +1. And now let's think about our upper and lower bounds. Over that interval, this blue graph is our upper bound. And so we would subtract the lower bound from the upper bound. So we would have x to the 4th minus 4x squared plus 1. And from that, we will subtract x squared minus 3 dx. And in many other videos, we have talked about why you do this, why this makes sense to just subtract the lower graph from the upper graph when you're finding the area between them. But now we just have to evaluate this definite integral. So let's just get down to business. All right. So we have the integral from -1 to 1. And so we have x to the 4th, and now we have minus 4x squared. And then when you distribute this negative sign, you're going to subtract another x squared. So you're going to have minus 5x squared. And then you have plus 1, and then you're going to subtract a -3. So it's going to be 1 plus 3, so it's going to be plus 4 dx. And just to be clear, I should put parentheses right over there, because it's really the dx is being multiplied by this entire expression. And so let's see, let's find the antiderivative of this. This should be pretty straightforward. We're just going to use the reverse power rule multiple times. So this is going to be, the antiderivative of x to the 4th is x to the 5th over 5. We just incremented the exponent and divided by that incremented exponent. Minus, same idea here, 5x to the 3rd over 3 plus 4x. And then we are going to evaluate it at 1, and then subtract from that, it evaluated at -1. So let's first evaluate it at 1. We're going to get 1/5 minus 5/3 plus 4. And now let us evaluate it at -1. So minus, let's see, if this is -1, we're going to -1/5, and this is going to be plus 5/3, and then this is going to be minus 4. But then when you distribute the negative sign, so we're going to distribute this over all of these terms. And so this is going to be, if we make this positive, this will be positive, this one will be negative, and then this one will be positive. So you have 1/5 plus 1/5, which is going to be 2/5, that and that. And then minus 5/3, so minus 10 over 3. And then 4 plus 4, so plus 8. And also we just need to simplify this. This is going to be, let's see, it's going to be 8. And then if I write, so plus, I'm going to write these two with a denominator of 15, because that's the common denominator of 3 and 5. Let's see, 2/5 is 6/15. That's right. 5 times 3 is 15. 2 times 3 is 6. And then 10/3, let's see, if we multiply the denominator times 5, we have to multiply the numerator times 5. So this is going to be 50/15. And so what's 6/15 minus 50/15? So this is going to be equal to 8 minus 6 minus 50 is minus 44. Minus 44 over 15. And so what is 44 over 15? 44 over 15 is equal to 2 and 14/15. So that's really what we're subtracting. We're going to subtract 2 and 14/15. So if you subtract 2 from this, you would get 6 minus 14 over 15, because we still have to subtract the 14/15. And then 6 minus 14/15 is going to be equal to 5 and 1/15. So just like that, we were indeed able to figure out this area.